Hi everyone. My name is Sanat. So originally I'm from Kazakhstan, but currently I'm living in Berlin and working at N26, which is a mobile bank. So today I'm going to talk about the Kotlin and domain-driven design. So basically, like my maybe first words about it would be like, do use Kotlin in backend, because like we are using it from 2016 and it's working like perfectly for us. I mean there was some problems, there was some like issues with it, but it's in production for like I would say 1.5 years. We have like 150 microservices, and I think around 50% of them are actually in Kotlin. So basically, my presentation today is not about the perfect way of cooking Kotlin and domain-driven design. It's mostly like, I would say, maybe tips and tricks from Kotlin point of view. It's mostly about the way we do it at N26, and yeah. So probably most of you know Kotlin. So who have ever heard about domain-driven design here? Okay, great. I would expect like a bit more people because like it's pretty popular now. Yeah, so then let's talk about it a little bit more. So what is domain-driven design? Domain-driven design is not a technology or methodology, actually. It's just a set of principles and patterns to help people who is involved in the software development process understand each other better. So basically, it's not a silver bullet. It doesn't solve all the problems that exist in the software engineering process, but it just helps to get there easier as much as it is possible. So one of the, so if you are interested in domain-driven design, I would definitely recommend to read those two books. It's a blue book and the red book. Those are kind of Bibles of the domain-driven design. So I would definitely recommend them. So one of the key principles of domain-driven design is basically ubiquitous language. Yeah, I know, it's kind of hard to pronounce, like ubiquitous. But yeah, so basically, what is ubiquitous language? It's basically the shared language between engineers and domain experts. Domain experts in like DDD term are the people who are representing the business, right? So it could be business analysts, it could be product owner, product managers. So it's the shared language to actually kind of let domain experts and engineers understand each other better. So one of the good examples of ubiquitous language would be basically the word account. So like I'm working in a bank, so like account for me is something where user's account, right? It's something where you put the money, where you send the money from, where you store the money, and like manage the money overall, right? But let's imagine that we are building some, I don't know, CRM, or we are using some CRM, right? From that point of view, user's account might actually mean the place where we store the data about the user itself, right? The first name, last name, birthday, address, and stuff like this. So it's like very important to identify those like possible misunderstandings in the beginning, so everyone who is involved in the process of development are on the same page. Another key principle of domain-driven design is basically bounded context. So bounded context is kind of meaning of the product, meaning of the domain or software that we are actually building. So we didn't do that intentionally we did not do that intentionally at N26, but basically bounded context for us are the microservices. So we have like, as I mentioned, like around 150 microservices. Each microservice has its own boundary. Each microservice handles its own domain and is responsible for it. Today, I'm going to kind of try to build this simple internet shop. Why internet shop? I know it's boring, but internet shop is actually has complex enough logic to show the strengths of the domain-driven design and Kotlin together. But from other point of view, it's intuitive enough for everyone, I hope, in the audience to actually know the basic principles, so I don't have to explain them because it's unrelated to the speech itself. Yeah, so as an example, we have basically an example of bounded context. We're going to have the bounded context of product, which you call like microservice of the product. This will handle the whole information about the product itself, like adding them, setting up the price, I don't know, managing them, adding some discounts and stuff like this. Another kind of bounded context or microservice would be the user. User bounded context will take care about the user information, address, I don't know, card number, to pay, and so on and so on. And the kind of last bounded context for us would be the cart. So cart bounded context will take care about the process of user purchasing the product. Yeah. And now we need to go deeper. Like one of the principles of the domain-driven design are basically aggregate roots. So aggregate roots are core part of the bounded context. It's basically the cluster of the domain object, which can be kind of treated as the single unit. So like if you're going back to our kind of internet shop, we have the cart bounded context or microservice, and inside of it we have the cart aggregate root, which takes care about the adding products to the cart, removing products from cart, adding some information to the cart, stuff like this. And the second one will be the payment, which takes care of actual payments for what user actually purchased. And that's not enough for the domain-driven design. We are going even deeper. And entities. So basically, entities are the components of the aggregate root. They have no meaning without the aggregate root itself. It means that if you extract the entity from aggregate root, it will probably tell you something about it, but you will not be able to see the full picture. It has to be mutable. Please remember this point, because I will come back to it later as one of the challenges that we had to face in Kotlin. Basically, entities are kind of the only place in the whole application where we are going to handle the business logic itself, the domain logic. And entities definitely should focus on software model instead of the database model. So I found it really hard for myself to switch between those two principles, right? Between those two concepts. Like all the time when I was trying to build something, I was thinking, all right, so how it will be stored? How will it look like in database? Will it make sense there? And stuff like this. But when you're going kind of DDD way, then you have to make sure that the model itself makes sense inside of your application, that it's easier to actually process the logic. So you should build your model based on this assumption. So as an example again, we have a payment aggregate root, and we're going to have 3 entities in it, which is active payment, confirmed payment, and rejected payment. And last but not least, concept of DDD are value objects. So value objects are basically describing the attributes of the aggregate root or the entity. It also doesn't mean anything outside of the aggregate root and entity. It has to be immutable. And the main difference between value object and entity is that value object doesn't have any identifiers. What it actually means, it means that we like don't kind of extract the value object from where it belongs. It belongs to something, which is entity or aggregate root, and it makes sense only in relationship with this entity. Otherwise, it's just meaningless object. So as an example, again, we're going to have the user aggregate root, it will have user information entity in it, and we're going to have the address. So basically, what is address? We are not going to have the address ID or something like this because we don't need that. It's some part of the user information entity which doesn't give us information about anything outside, so it doesn't have its own identity, but you can actually point to it from the entity itself, and yeah, treat it as a value. And yeah, so layers. Like in DDD, it's very important to actually differentiate where you put your logic, where you put your classes, implementation, stuff like this. So DDD implies like 3 different layers. The first one is application layer. It's mostly for data transfer objects, for converters, for some application services. The most important thing about the application layer is that it must not have any domain logic in it. So the responsibility of the handling of the domain logic is basically the responsibility of the main layer. So in the main layer, we are going to have aggregate roots, bounded context, entities, value objects, and so on and so on. So the domain logic itself. And the infrastructure layer is taking care about the implementation of persistence. So it's like where you store your data, or it could be some entry points, like, I don't know, some REST services, or listening to some queues. It could be basically some notifications. So it's like something which allows us to actually communicate with other services, I would say, other entities outside of our application itself. So if we'll have a look at the picture overall, so we're going to have basically user and card bounded context. Inside of it, we have the user aggregate root, which holds the entity, which is user information, and the value object, which is address. And for card bounded context, we're having the card aggregate root, which holds the card entity, and the payment aggregate root, which holds the 3 entities that I mentioned before. And now one more thing. This is not the fully DDD term. It's the use cases. Basically, when we were working on this, developing in this domain-driven design way, it's not that easy. So it also implies a lot of stuff like commands, events, handlers, maybe even like CQRS or event sourcing and stuff like this. So not to make the logic too complicated, we found these use cases as kind of interim solution. It totally works for us. I will show a couple of examples later. And I think it makes sense at this stage of working in domain-driven design way at N26. Use cases actually make sense. Yeah, so as I promised, the example of the use case would be add product to the cart use case. So when you're invoking, it's like we have it's like we are trying to find the cart by the user ID. If cart is not found, then we just create a new one, and then add it add the product to it actually. So the use cases that I'm going to cover today, basically those. It's add product to cart, remove product from cart, process cart to payment, confirm payment, and reject payment. So now this was kind of small introduction to domain-driven design and the way I interpret it. So let's now switch to the implementation itself. So the first implementation would be the entity named cart. So this data class is basically entity. It is data class, which the name of data class says for itself. So it's some class which actually managing some data, right? So we have 3 fields in it, 3 variables. It's cart, user, and list of the products. I personally fan of the vals, final variables in Kotlin, because they're immutable, and I like immutability. It gives you the possibility to not worry about the multi-threading programming, right? It also gives you the possibility to actually at least try to write the functions which has no side effects. And if you can run the functions which has no side effects, it means that you can actually try to test it better, and you can be sure that there is no codes, no bugs, and I don't know, some stupid null pointer exceptions, which is not possible in Kotlin, but it's like I actually was able to get one null pointer exception in Kotlin, but it was in test, so yeah. So this is, as I mentioned before, this is entity. And the first problem that we faced when we were trying to implement domain-driven design with Kotlin is basically what we have to, is that entity has to be mutable, right? I mentioned it before. And our variables inside of our object are basically immutable. So what it means for us, we cannot change the variables inside of the object, but we have to find a way to actually kind of, I don't know, store them, right? We cannot do the dependency injection inside of the data class. It wouldn't make any sense, right? So one of the kind of ideas, it's like credits to my colleague in Barcelona, Odin Del Rio. So he proposed, and I really like this idea, is basically passing bins inside of the entity object itself. So how will it look like? Would it look like? It's basically like this. So we have like 4 functions in it. So it's like save, add product, remove product, and validate. So basically, how would you read it, right? So if you would like to save the cart, it means like save cart to this cart repository, or add product to this cart repository from product repository this product ID, and like remove product from this cart repository this product ID, right? So, and like validate, but I will talk about it a bit later. So the whole idea is basically something like this. I found it like really, I would say, crazy when I first like saw the code like this. I was like, does it even like make sense, you know, to make it like more complicated, to pass more parameters and stuff like this? But if we wouldn't do that, then it would lead us, and put this logic somewhere outside of the data classes, then it would lead us to the anemic models. Then we would have just a simple set of functions which are basically doing nothing. And that's what DDD is actually like dangers us. Like we shouldn't do it this way. We shouldn't have the anemic models. And it's very important to actually solve this problem. So if you want to have a look, how does the add product and remove product look inside? So it's pretty simple. It's like we get the product from the product repository. We add it to the list of the product and save it to the cart repository, basically. If nothing found, it throws the product not found exception. And same with remove. Like we're trying to find the last one. If it's there, then we remove it from the list and then save it to the repository. So how would repository look like in this case, right? Because as I mentioned before, all the persistent logic doesn't belong to domain itself. It belongs to the infrastructure layer. But what it means for us is that we have to implement some interface which will be the part of the domain itself. So domain defines which methods domain needs to perform the certain logic. And then in the infrastructure layer, we'll have to implement the implementation of this interface, which could be anything. Like it could be some Postgres, insert to the Postgres database or Oracle database, wherever. It could be some, like send it to another microservice, right? It could be put it to some queue or emit some event. So we don't care about it at domain level. So it's just what we care about, that we have certain functionality to implement our logic and process our logic. Yeah, so states. So, and like another thing that I found like really beautiful in Kotlin is the way how we were able to actually handle the states. This is very hot topic for us at N26, and it's like very important to like to find something in there. So what we found like really useful in Kotlin is basically the seal classes. So seal classes is basically constraint hierarchy where like object can be only of one of the given types, and it gives us possibility to actually store the state of the object itself. Yeah, so what I also like about the seal classes is that you cannot actually extend the seal class outside of the file where it's declared. So it actually means that you have to do it in the same file, and it means that the whole logic is in the same file. It's not like spreaded by the domain, or it didn't leak to another layers. I can make sure that if I want to find something, I'll find it. And seal classes are helping a lot with that. So the example of the seal classes would be the payment seal class. So we have like 3 fields: ID, amount, and user. It's pretty simple, and it's like the only one function which is save. So it's also save to payment repository. Pretty straightforward, I believe. And this payment class is going to have like 3 states. So the first state is basically active payment. So active payment is extending the payment seal class, and basically has like 3 functions, which is process, confirm, and reject. So what it means for us is that we don't have to worry about like about what state it is now, right? It's like we don't have to add some like conditional operators, like if state is, I don't know, like active, then perform this logic. If state is, I don't know, confirmed, then perform this logic, and stuff like this and stuff like this. So it's like we have it already in our entity classes. We have the functions which are available for those entity classes, which can be performed in those entity classes. And those are, I would say, makes the process like easier of implementing the logic. So, so yeah, a little bit about the logic. So the process is pretty straightforward. It's like process, basically, the payment can be in active state when user just initiated the payment action. So basically, when user clicked like I would like to pay, we create some like payment class which is in active state, active payment, and then we just process it to store it to database. So we validate it. Again, I will talk about validation a bit later, and just save it to payment repository. And then user, not the user, but the system can confirm the payment, which will convert it to the confirmed payment state and save it to the payment repository, and also reject, which is basically rejected state, and save to the payment repository. So this is how the confirmed payment and rejected payment look like. I would say pretty simple, and it's really easy to understand actually what state it is based on the names. But then let's say your PO is coming to you and saying like, all right, Sanat, so we need to implement new functionality, which is basically we want to refund the payment, but the refunding is possible only if the payment is confirmed, right? And can you see the names? It's like the terms that the PO is talking is basically the same terms as you name your entity classes or value objects or aggregate roots, because this is the main idea of the Ubiquitous language itself. So it's like the PO is coming and saying, all right, so let's say that we're going to have the functionality to refund the payment. It's possible only from confirmed payment, because otherwise we didn't get money, and it doesn't make much sense. So what are we going to do? It's going to be pretty simple as well. So we're going to introduce the new interface, which is refundable payment. It's going to have like the same fields, and then it will have the only function refund. So refund function is doing something inside. We don't care about that. It's basically the refunding some amount of money, returning back to the user, and that's it. And then what we do is pretty simple again. You just extend the confirmed payment class from the refundable payment, and this functionality, anytime when you load the confirmed payment class again, you will be able to refund it, but only the confirmed payment class. It won't be available for rejected because we don't extend it from there. And yeah, then you probably will need to store the state of kind of refunded payment, which is also shown as an example. And then let's say at some point you will need to understand what state it is. And here is another thing why I love actually seal classes, is that you don't have to implement any else. If your payment object is not null, you don't have to worry about will it actually be in this state or not, because all the states, all the possible kind of implementations of the seal classes are there. So the compiler knows itself that there will be no other kind of implementations, and we don't have to implement else. And I believe it's beautiful. I mean, this is working compiling, so just in my opinion, it's just great. Yeah, so as I promised before, let's talk a little bit about validation in domain-driven design and how Kotlin helps in there. So basically, this is the function validate. It's very important in Kotlin to take care about the validation itself, because you basically do that inside of the object itself. So in our case of the payment, we would like to validate that the amount is more than 0, otherwise throw an exception, or the user has card number confirmed or defined, and then if not, then just throw an exception. So yeah, as you see, it's pretty simple. First of all, this is what DDD gives us, but also what we don't have to care about because of Kotlin, of course, we don't have to check the nullability. If the variables are there, we just don't care. We just trust, and it makes our life easier. Now, a couple of words about testing. I think I'm going to cover only the unit testing because my time is, not I cannot speak forever. But actually, the testing is also pretty simple if you are going the right approach with domain-driven design. Basically, we create some active payment, confirmed payment, mock the payment repository. We actually use Ubiquitous for unit tests, and we use Kotlin test pretty often. So yeah, basically this is simple test to test kind of save payment to payment repository, which is just verifies if the save function was invoked. But then, what if we need to actually test the active payment class? Do we have to implement it in again one file and then put the whole logic into the same place? Kotlin also gives the the inner classes. In this case, the inner classes from the inner classes you are able to actually access the fields, the private fields of the parent class. So this is also becoming straightforward. So our test should process the payment to the payment repository. We also verify that it's fine, but we also have to check what if amount is 0. Then we do expect the exception and basically verify that save function of payment repository was never invoked. Yeah, so even though domain-driven design is pretty cool way of development, I would say, it has its own disadvantages. First disadvantage, I would say, it's really hard way to follow. You have to make a lot of preparation work to get there. You have to align a lot of people who is basically all the people who are involved in development all together to actually implement the Ubiquitous language. So that's why it's consuming the time a lot in the beginning, and it's you have to learn or teach and learn yourself the stuff about the DDD, the best practices, and stuff like this. But then if you did that, it works just perfectly. And one more advice about the domain-driven design, it's don't do domain-driven design if you don't have complex business logic. If your application is simple CRUD, don't do DDD. It just doesn't make sense. You will just spend the time on it. If your application is doing some, I don't know, low-level bit stuff, don't do DDD. It will not bring you much value. Do DDD when you have the some huge enterprise application, when you need to make sure that your logic is actually in one place and it's easier to find how it works, and so on and so on. Yeah, so if you have any questions, shoot them now or be silent forever. Yeah. Yep. I just don't hear it, sorry.
Okay, now with the microphone,
Yep.
hi. First question, why do you use data classes for entities? What is the motivation behind that?
That's a good question, actually, yeah. I think data classes are just, yeah, they just made sense for us when we actually started like going domain-driven design way is the first thing. And second thing, it's again, domain-driven design is like the objects that we have, the entities, also having some data, right? So we have to manage this data. So that's why I believe data classes are basically a perfect match.
Okay, thank you. And the second question I had, you showed some methods which get multiple parameters with repositories.
Yeah.
And you mentioned that you cannot inject them into the entity.
Yeah.
Can you tell why? So I expected to see some kind of factory there which is injected with repositories and then you create your card object?
Yeah, I mean, that would work as well. It's basically, we could do it this way, but then what if you don't need the whole repositories, the whole dependencies that you're provided in the card? Because like you might end up with the like whole bunch of the like dependencies that you're injecting, and then you won't need them, for example, in some like methods. So why would you create the whole object and like pass the whole stuff in there just to actually, which will not make much sense.
Okay, thank you.
Yeah. Any other questions?
Hi, I'm currently working on a bigger project that also has some really complex business logic in there, and we just recently started trying to move to a domain-driven design. And of course, it's a long incremental way there. But now you mentioned that the models in domain-driven design, the domain models should be software-oriented and not based on the database.
Yes.
Now, of course, because this is not really a legacy project already, but it's going for several years now, our whole business logic is built on the database models so far. Do you think it would make sense to rethink our whole domain models now when we tear them apart? And a second question that's kind of linked to this, what do you think about sharing models between domain and infrastructure layer, like with interfaces or something, to actually have the models you implement in your infrastructure layer in the business or in the domain layer?
Yeah. You basically answered your question yourself. Yeah, first thing I would definitely propose, if you're going DDD way, I would definitely propose to read the Blue Book. It's like Eric Evans, who is the writer of the book. He writes a lot about the distillation, about the separation and stuff like this. But regarding your stuff, it's like the best way would be to actually build your own domain model, which fits your domain, first of all, and keep the database model that you already have in the infrastructure layer. So, and basically convert in between. So when you like pass the object to persist, then you just convert it on the fly and then just store it to database. This would be the best way. I know it's not always possible, but this is the proper way to do it. Yeah, did I answer the question? Okay.
Hi, I'm also working with microservices, and we also do converting currently in Java. We use Model Mapper for that. Is there any Kotlin way for doing the conversion, or do you use automatic Java converter like Model Mapper for converting between the layers?
Sorry, I just didn't get the question. What was the question?
Do you have some specific Kotlin feature in mind which helps you converting? Or do you use the same converter logic like model mapper, the tool model mapper,
Yeah.
as you would in Java?
I mean, it depends on the task, right? So if the task itself is it's like if you need to actually implement some like custom logic, then like go for it. Go for some converters and stuff like this. But if like wherever you're using like model mapper, right? So if it's like enough for you, then why not? If it's working for you. But it's like nothing like from the top of my mind that would actually be maybe helpful like now. Sorry. Yeah, so any other questions, please? Cool, then, yeah, so we are hiring. It's like N26 is growing really fast. So if you ever thought about moving to Berlin or Vienna or Barcelona or New York, then try to check out our page and maybe you'll find something suitable for you. You will be able to use wherever you want. And you have to put it to the tech radar first, but then you will be able to use it actually. So I think it's a great place to work. And I would like to finish my presentation with this amazing quote from Martin Fowler. Like, it's any fool can write the code that computer can understand, but only good programmers write the code that humans can understand. So from my point of view, domain-driven design and Kotlin are serving the same goal, which actually make people's life, people's communication between each other easier. And I think it's just great. Yeah. That's why they're natural partners. Thank you very much. Enjoy like another talks, and if you have any questions, feel free to reach me. I'm always around.